Good morning students, hope you all are fine. So as we are doing the method of separation of variables, so to continuing with the same topic, this is another question of type 2 of the same topic. For example, if you get a question like this, that using the method of separation of variables, solve this equation where u at x comma 0 is equal to this. That is, the non-homogeneous equation is given to you and an initial condition is also given, right? Now in this case, how to solve it? First of all, as we did in the last question that we did yesterday, that was of type 1, in which as we have taken the function u as a function of capital X and capital T, where capital X is a function of x alone and capital T is a function of t alone. You can check from your equation that this u is your dependent variable and x and t are independent variables. So u is depending upon x and t. So that's why we have taken u is equals to capital X into capital T. Let it be our equation number 1. Always remember this capital X is a function of x alone and this capital T is a function of t alone. Okay. So we have to now find out these values, curly u over curly x and curly u over curly t, from this equation. So we will take its derivative with respect to x. This implies the derivative of this function capital X, it will be x dash and this t will be as it is. And for curly u over curly t, x will be as it is and the derivative of this t dash. Now we don't need any derivative of second order in the equation, so we will limit it up to here. Now put these values in this equation. Substituting in given equation, we have at the place of curly u over curly x, we will put x dash t equals to this 2 as it is. Curly u over curly t, its value is capital X t dash plus this u. Now what is this u? U is equals to x into t. So we will put it capital X into capital T. Now as the method tells us that we have to separate the variables to solve, so we have to separate the variables. So what we did, we shift this x into t on this side, then this t is taken out common. Now we will shift this t to this side and this x to 2x to this side. So now this x dash minus x over 2x is equals to t dash over t. Now as I told you yesterday that this term contains only variable x and this term contain only variable t. So if they are equal, this means their result will be equal to the same number, the same constant. So we have put that this term will be equal to this term if they both are equal to some similar number. So we have put it equals to k. We have supposed this that they two are equal to k. Now first of all we will equate this term with this k, then we will equate this term with this k. Now starting with this one, that is x dash minus x over 2x is equals to k. So this 2x can be shifted to this side. So it will become x dash minus x minus 2kx equals to 0. Or we can shift this x minus 2kx on this side. So it will become x plus 2kx. X can be taken out common and it is x dash is equals to x into 1 plus 2k. Now this x can be shifted to this side and it will become like this, x dash over x, which is equals to 1 plus 2k. Okay, now solving it, we have to solve it. So integrating on both sides, as we know that the differentiation of the same function is in the numerator and the function is in the denominator. So its integration will be log of this function, that is log x, which is equal to, now this is constant, so its integration with respect to x will be the constant as it is into x plus the constant of integration c1. We have taken here log because the log is present. Now the log is not here in this term, so we can write this term like this. As we know, log of e raised to power x is equals to x. So keeping in mind the same property, we have written it log e raised to power this function. Okay, now log m plus log n, it will be equals to log m into n, right? So this will become log of this function into this function. Now log of x is equal to log of this function, we also know that if log of m is equals to log of n, this implies m is equals to n. So x will be equal to c1 e raised to power 1 plus 2k into small x. So this was all about this equation, this equals to this. Now we have to solve this one. That is t dash over t is equals to k. So we will come to this one now. So t dash over t is equals to k. So now integrating both sides, again the same property, the function itself is in the denominator and its derivative is in the numerator. So its integration will be log t, which is equal to, now this is constant, so its integration will be the multiplication with the variable with respect to what we are integrating, that is t, plus the constant of integration. Here we have taken c1, so here we have taken it c2. The log is taken with the constant of integration, as we will be having log in all the terms. We can write this k into t in this way, as we have done here. Similarly, this k into t can be written log of e raised to power kt. Now again log m plus log n is log e raised to power kt into c2, and log m is equal to log n will become t is equal to c2 e raised to power kt. So here we got the values for capital X and capital T. So these two values we have to put here in this equation number 1 and we will get the solution. Right. So we will put these values, this one and this one, in our equation number 1. So equation number 1 will become, this is our equation number 1, that u is equal to x into t. So it will become value for x, that is c1 e raised to power 1 plus 2k into x, value for capital T, that is c2 into e raised to power kt. Now this is our required solution, but in our question the condition is given, the initial condition is there, that when t is equals to 0, so the value of this function will be equal to this, right? So what we will do here, we will come back to our solution and we will put t equal to 0 in it. So when put t equal to 0, it will become u x comma 0. On this side the t is present here, so t equal to 0 means e raised to power 0, that is 1, right? So it will be left c1 into c2 e raised to power 1 plus 2k x, right? Now its value is given as 6 e raised to power minus 3x. So this will be equal to this one. Now if we equate this left hand side to this right hand side, what we get? That 6 is equal to c1 into c2. Now e raised to power minus 3x, e raised to power 1 plus 2kx, right? So if e raised to power m is equals to e raised to power n, this implies m is equals to n, right? So this way minus 3x will be equal to 1 plus 2k into x, right? Or if we equate the coefficients of x only, then minus 3 will be equals to 1 plus 2k. From here we can find out the value for k, that will come out to be minus 2, and 6 is equal to c1 into c2. So this is the value for the product of the constants and this is the value for k. Put these two values here in equation number 2. So this will reduce to this one. How? This uxt will be as it is. At the place of c1 into c2, we will be having 6 from here. At the place of e raised to power 1 plus 2k. Now k is minus 2. So minus 4 plus 1, that will be minus 3x. Here at the place of k, I will put minus 2, it will be minus 2t. I can combine these as the product is there, so the powers will be added. So I can write it in this way also. So this is my required solution. So this is the question of type 2 in method of separation of variables, when a given condition is there and you have to find out the values for the constants, right, and get your solution. So thank you so much. Revise this topic, and today I will give you an assignment also based on the solution of non-homogeneous equation. I will share this in your Google Classroom, so you have to solve it till Monday and send me the scanned PDF in your group. Okay, thank you students.